Okay, so I'm working on adding buckets of features to GenCAD and making it so it runs on Linux. Now, there's been a couple of things. I've been working on the same sort of environment on Windows, and for some reason I'm getting about 100 times performance on Linux over DOS, and maybe a 30 or 40 times improvement in performance over Windows. I've been trying to dig down to the bottom of it. There appears to be two places where there's the difference, and that is one from how it handles file access. So if you get small chunks of data off a file, Linux seems to cache it better. And the other one of all things is just printing a number on the screen, printing text on the screen. That seems to be a tremendous overhead on Windows. They must have, on their API, kind of ignored optimizing that or something. I don't know what they've done. And I've played with the Windows subsystem for Linux as well to try and get the same speed out of Windows, but it seems to be baked into the hypervisor underneath it all. So I don't know, can't seem to work around that. Anyway, to demonstrate what I'm talking about, I've got a thread design. That's this guy here. Doesn't look like much, just a lot of code, right? About this third of the code, from about here to about here, with the commands that I've added, I should be able to delete with the new thing, but I haven't bothered because I'm just testing it as is. My focus is working on actual software, but I'm using a script, so I'm using a regular text editor to edit the actual GenCAD file, because I haven't written my own editor yet for Linux. I may not either, because this works so well. Right, so I'm using a kind of a shell script. Where are we? There we go. This G3D sh will basically load thread1.gen, so it's loading it off the computer, off the hard drive, loading the interpreter, crunching through the design, then throwing it up on the screen. Now you'll see that it's pretty quick. You'll see what I mean by the speed difference. Now this design is about 100, I think it'll come up on the screen, 116,000 points. So you can see how ridiculously fast it is. It's 116,000 points, all individually created, and they're up on the screen in 3D. So I've got the rudiments of a 3D display now. I also, this window, actually I'm not quite sure what the size of this is, but you can see this is a 4K monitor, and that's, what is that, about a third of a 4K monitor? So I think it's about 1280 by 1024. I think that's what it is. That's about a 3:4 aspect ratio. I haven't actually measured it. I just haven't got there. Anyway, so I thought that might be interesting to you. The crazy speed, it's coming. I also have worked out how to generate shells, but I've had to build the display program around 3D, and I've also had to bump up that resolution, because you don't, the old 640 by 480 display obviously on DOS is just too restrictive. This is, without changing my code significantly, this is the highest resolution I can do without rewriting the language significantly. So I'm kind of doing a kludge, or a half step or something with this display, but I'm building up sort of the technology of it. And yeah, so I hope that's of interest to you. Like, it's coming. This design here, this 116,000 points, I've got a similar design which I used OpenSCAD to create the thread, and so it's sort of the outside shells, and then put it through a slicer to generate all the paths that the printer takes. The problem you have with using a slicer is you don't actually have control over what the printer does, like you don't have control over the tracks. Using this method, you can control everything that the printer does. I'm intending to have a one-line parameter parser from GenCAD to type in the parameters for 3D printing. So, the temperatures, the speeds, and all that sort of guff, all in one line on GenCAD. So it'll be very quick. I'm also aiming to have GenCAD so it saves maybe an SVG in 2D. This kind of G-code path, so that GenCAD's already creating G-codes with these 3D tracks. And also create STL. I don't know whether you're aware of it, but GenCAD can save multiple files. What I'm going to do is make the file saving automatically break up the multiple files. If it's a 2D file, it'll save it as an SVG, and a dig file so you can laser cut it, or SVG so you can import it into other 2D programs. G-code so you can take it directly to like a 3D mill or a 3D printer. And STL so you can take it into slicing software or post-processing software. So that's where I'm at so far, and I've worked out how to facilitate the different modes on the fly in GenCAD. So simultaneously your design can have a number of 2D parts, a number of 3D shells, and a number of 3D tracks as separate files within your one source file. So you don't have to, if you've got a whole lot of parts that have to fit together, say a couple of laser cut, a couple of 3D printed parts, and a couple milled with a milling machine, they can all be built as part of the one design. And so that's where I'm going with this thing. And I've done kind of the rudimentary, kind of the subsystems that I can build upon for that. Of course, there's going to be heaps of bug fixing and whatnot. But yeah, so it's coming. I hope that's of interest to you. Leave it at that. And bye for now.